Hello Ninja Warriors, welcome to yet another power packed session, and in today's session we are going to start with the topic differentiability, right? So in this session we are going to cover the basics of differentiability, what is differentiability, and in previous lectures we have covered what is limits, what is continuity, right? Before I start any further, am I audible? Am I visible in the chat box? Yes, can you guys confirm? Am I audible? Am I visible? I can see Gokul. Hello Gokul. Hello Kush Mohit. Good evening. Abhishek. Okay, you guys know that it's my birthday today. Thank you. Thank you Kush Mohit. Thank you Gokul. Thank you for the warm wishes. All right. So now are we ready? Are we ready for the session? Are we ready for differentiability? Just let me know. Are we ready for differentiability? Am I audible? Give me a green signal. Give me a big thumbs up if I'm audible and visible. All right. I guess you guys have given me the green signal. I'm audible as well as visible. So now, for all of those who don't know me, who are coming for the very first time on this channel, or who are attending my session for the very first time, this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience, and I have taught in various reputed institutes across the India, taught and mentored 10,000 plus students. I don't even count now because in online we can't keep a track how many students I have mentored, and my previous students are studying in various IITs, NITs and other engineering colleges. Okay. All right. Thank you. Thank you Kush Mohit. Thank you so much. All right. Now we'll start with differentiability. Okay. So in previous lecture you know that we have covered continuity, right? Do you remember? Let me give you a quick recap about continuity of the previous lecture. So I have already told you that the ninth grade is your limits. If you pass in your ninth grade, then only you'll get promoted in your 10th grade, right? So then only we will talk about the continuity. So if limit of any function exists, then only we will talk about continuity, okay? Right? So that's why if a student has been passed from ninth grade, he or she will get promoted in 10th, and once he has passed his or her 10th grade, he will get promoted in 11th, right? So that is what we call as differentiability. Yes. Okay. And also, if you have not liked the session, what are you waiting for? Are you waiting for something? Do like it right away, okay? So yes, limits, continuity and differentiability. The order of studying the all three topics should be like this. If you don't know what is limit, you won't be understanding that what is continuity. If you don't know what is continuity, you won't be understanding what is differentiability, okay? Now let me just give you the simple definition of limits. So if I talk about, there is a function and we are talking about x equals to a, okay? So limit of a function where x is tending towards a will be equals to limit of that function where x is tending towards a minus is equals to limit of that function where x is tending towards a plus. That should be a finite quantity, by the way. That should be a finite quantity, right? So this is the definition of limit. Just the LHL should be equals to RHL, and that should be a finite quantity. This is what your limit is. But if I say that my function is continuous, right? So there will be one more step added. In this case, again, left hand limit of that function should be equals to right hand limit of that function. That means the initial condition limit so definitely should exist, but now this time for continuous, the value of this limit should be equal to f of a, value of the function at exact a, okay? So this is again LHL equals to RHL equals to f of a. Now if that is also done, like, so this is what your continuity says. Now we are at the last step, which is differentiability. Okay. Now to understand differentiability, we need to understand some things. Like graphically, we have to understand a few things. Okay. So if you want to understand differentiability, you have to understand a few things. Are we ready to understand? Are we like, yeah. So you have to understand the concept of tangent. To understand differentiability, trust me, we are doing it from very basics. Huh? Nobody is going to teach you such things, like such little attention, details. Okay. So yes, first of all, let us understand the concept of tangents. Okay. All right. So what is a tangent? Can anybody tell me in the comment section? Can anybody think about it? What is a tangent? So if I have any graph, any curve, any function whose graph is like this, suppose the graph is like this, okay? And now I will draw a secant. Over here I will draw a secant. So a secant will look like this. What is a secant? Secant is something which will cut the curve at two different points, A and B, right? And what if I tell you that A and B both, I want both should coincide. If you want your A and B both should coincide, then this is your this is your this, and if you want your A and B to be coincide, then what will happen? Your secant will become tangent and it will touch your curve at single point. So A and B both are becoming same, right? So basically tangent, if I tell you the definition of tangent, can I write tangent is the limiting case, limiting case, oops, the limiting case of secant. Limiting case means that your AB, this AB length should be tending towards 0. The moment AB length should tend towards 0, what will happen? Your secant will become tangent and it will touch your curve at single point. This is what we know about tangent. Let me know that if you understand this nicely, if you have understood this nicely, okay? Okay, so Kushmohit is telling me the definition of tangent, a line draw to a circle or curve, but a line draw which will curve at single point. Okay, this is the proper definition. I hope you understand that. Now let me just tell you that over here, yes, suppose you have a curve, correct, and suppose you are having a secant. So let me just mark it as P, and this is your Q, and this is your Q dash. Okay, so PQ is one secant and PQ dash is another secant. Okay, so I have drawn two secants from this point P, correct? And now if your understand, now what I want is my PQ. If my PQ becomes 0, then what will happen? Tell me, if my PQ becomes 0, then what will happen? From the right hand side I will have a tangent, but from the left hand side I will still have that secant, yes or no? If I say that my PQ is tending towards 0, okay? And if now one more thing, if this time, so see at P point we have tangent. Now if my PQ dash also tend towards 0, then what will happen? From here also I will have a tangent. So both sides, if I get a tangent from both sides, then what will happen? I will get a proper tangent. Getting it? Yes, till now? Okay. Now what I'm trying to tell you is that you will be able to draw a tangent on this point P. If I just keep this point P as the main point. Now what do you want? You want to draw a tangent at point P. What does that mean? That this secant, PQ secant and PQ dash secant, both will become tangent at the same time, right? That means slope PQ should be equals to slope of PQ dash eventually. Eventually, right now it is not happening. See, right now what is happening? PQ is different, PQ dash is different. So both are two different lines. But eventually, can you see? Like the third diagram says that this is your PQ and this is your PQ dash and this is one single line. And if I talk about slope will be same of this, right? So PQ is going to become this tangent. PQ dash is also going to become this tangent. So can't I say that slope of PQ and slope of PQ dash is equal to, both are equal? Yes. Can't I say slope of PQ and slope of PQ dash both are equal? Now I'm going to tell you the condition of differentiability. Hear me nicely. Suppose P point, this is P point. This P point, let's say this is x equals to A. And this Q dash point is x equals to A minus H. So we are just reducing something like a very little thing from A. And on the right hand side, can you see Q? This is x equals to A plus H. Correct? X equals to A. Now this is f of A. This is f of A minus H. And this is f of A plus H. Correct? Okay. So basically the y coordinate of Q will be f of A minus H. So if I just write x coordinate comma y coordinate. This is A comma f of A. And this is A comma f of A plus H. Correct? Okay. So now let us write down the slope. Do you know what is the slope? Do you know how to write the slope? So slope of PQ will be what? Y2 minus Y1 upon X2 minus. Correct? Slope of PQ will be what? Y2 minus Y1 upon X2 minus X1. Correct or not? Yes, ma'am. Now what is Y2? Y2 is this thing is Y2. F of A plus H minus F of A. So this is your Y1, this is your Y2 upon, this is going to become A plus H. The x coordinate of Q point will be what? A plus H minus A. So x1 is A, right? So A cancels. So what are you getting? F of A plus H minus F of A upon H. Correct? This is the slope of PQ. Are you getting it? Are you understanding it? Right? This is the slope of PQ. Now similarly, if I find the slope of PQ dash, so MPQ is equals to MPQ dash. Slope of PQ is F of A plus H minus F of A upon H, and slope of PQ dash is, by the way, F of A minus H minus F of A upon minus H. Okay. So if both are equal, if these two are equal, then what will happen? You will be able to draw a unique tangent on that point P. Yes or no? So basically here H is tending towards 0 positive. H is a small positive number. Okay. So if these two are equal, then we can say that my function is differentiable at x equals to A. Okay. And also let me tell you that just like the limits chapter, left hand limit, right hand limit, in this differentiability we call this expression as right hand derivative and this expression as left hand derivative. So what does that mean? If your right hand derivative is equal to your left hand derivative at that point x equals to A, understand, everything we are doing at a point x equals to A, then only we can say that okay, my function fx is differentiable at x equals to A. Now you must be wondering, ma'am, hold on, this is a very big formula, f of A plus H minus f of A upon H. We don't know, like we will be able to put the values, we will be able to understand this or not, okay? So let me tell you that do not worry, I am here, right? I know that what will be difficult for you for the very first time, you will find it very difficult. For the first time you will be finding, okay, this is like too much for me. But don't worry, your Ninja Ma'am is here, right? Ninja Ma'am will tell you ninja technique to simplify things, right? So don't worry. You will be able to see that the conceptual part maybe the Ninja Ma'am is going in very depth, but when it comes to problem solving, I am going to give you such basic ninja techniques, and you'll be like, okay, the whole question is like extremely easy, and math is mathing these days. Okay, all right, thank you Shivani, thank you so much. Okay, all right, and we'll do KCET problem as well. Okay, now I'll be telling you, so there is one definition of, one definition of differentiability. What did you understand? That right hand derivative is equals to left hand derivative, and there is a formula associated to it that you have to remember. I will be like telling you later on also. Okay, now the second definition of differentiability, the graphical definition. So differentiability has a definition: a function is said to be differentiable at point P if it has a unique tangent of finite slope at point P. Hold on, understand what I'm trying to say. Suppose this is your curve and this is your point P. Now you just have to understand that at point P, tangent on it, if you are able to draw, then that simply means that this function is differentiable at point P. Okay, in other words, we can say that if a function is differentiable, if it does not have any jump, or we can say break, or sharp corner. Now this is something new, sharp corner. Jump, break, to we know. We have seen this in limits graph. We have seen this in continuity graph, that graph should be smooth. We should not lift our plane. We should not lift our pen while drawing the graph, while drawing the curve. There should be no break in the graph. That is fine. That is applicable for continuity as well. But in differentiability, there should not be any sharp corner. Okay, let us understand with the help of a few examples. Okay, so now I will ask you. Okay, you might have a fair understanding of differentiability by now. Okay, what is differentiable, what is not differentiable. Let's make it more interactive, let's make it more engaging. I will give you a graph and you have to tell me in the comment section that, ma'am, is it differentiable, is it not differentiable? Okay, so let's do this. Okay, now this is your graph. Just tell me, first thing, this is x equals to a. You have to tell, is it like limit exists or not? First question. Second, is the function continuous? Third question, is it differentiable? Okay, in the chat box. Okay, now limit should exist, or limit is existing or not? Obviously at x equals to a, what is happening? The left hand limit is different. Can you see the left hand limit is this, right? This value. What about the right hand limit? If I approach the function from the right hand side of a, the value is different. So LHL and RHL are both not equal in this case. Can you see there is a break in this graph? If there is a break in this graph, then the function is discontinuous definitely, and eventually it is a non-differentiable function. So this is non-differentiable and discontinuous function. Okay, yes, you guys are not telling me in the chat box. All right, cool. Chalo, let's just talk about this thing, this situation. Can anybody tell me what is happening over here? Okay, so this is again a function. Again, you have to tell me whether at x equals to a limit exists or not. So limit will exist, because if you approach the function from the left hand side and if you approach the function from the right hand side, you will get the same value. So limit will exist. The function is continuous as well, because you see how I drew this graph. I drew without lifting any pen. Basically there are no break for graph. Can you see here there is break, but here there is no break, so continuous. But what about the differentiability? Can you see now there is a sharp corner over here? Whenever there is sharp corner, the function is non-differentiable. Yes, yes. Thank you, Sangappa. Thank you so much. Thank you for lovely wishes. Okay. Give time to type in the chat box. Okay, okay. All right, all right. Now, one more graph. Chalo, let's see. One more graph. Let us talk about this graph at x equals to a. Now I'll be giving you time to write in the chat box. Yes, Kushmohit, are you typing? So again, can you see that only sharp corner is observed? There is no break in this graph. So limit will exist. Function is continuous, but differentiability, no differentiability, because there is a sharp corner over here. Are you getting my point? Okay. And last, one more thing I would like to mention. This is a special case, by the way. You all should know, right? So suppose you are having this graph, not this. Okay, this graph is there. So just tell me at x equals to 0, is it differentiable? Let's see how many of you are able to tell. Yes, Kushmohit. Yes, absolutely right. At x equals to 0. So I can see limit is existing, the function is continuous, and if you are able to draw a tangent over here, can you see there is this tangent? You are able to draw a tangent over here. Okay. Alright, so this is a tangent, but can you see the function will still not be differentiable? What happened, ma'am? What happened this time? Okay, Abhishek is saying non-differentiable. Can you just tell me the reason of non-differentiability? I'll be super duper happy if you exactly know what is the reason of non-differentiability over here. So clearly we can see a vertical tangent over here. What is vertical tangent, ma'am? So basically the tangent is at 90 degree from the x-axis. The slope of tangent is not finite. Slope of tangent is infinite. And do you remember? Let me just go back and talk about the definition, that tangent should be of finite slope, right? Tangent should be of finite slope. Correct? So tangent is there. You are able to draw the tangent, but this is a special case. Whenever you see there is a vertical tangent, that means tangent you are able to draw, but still the function is not differentiable. Are you understanding this? Okay. So this is a very special case. Not many of students will be able to tell this thing, right? Okay. Now we have studied concepts. The concepts are very strong now. I don't think so that you will need any other definition, any other theory for the differentiability. But now let us understand that how to tackle the problems. Okay. So now understand problem solving. So for differentiability, I'll be teaching you three methods. Okay. Three methods. Method number one. Method number one is by LHD and RHD. Remember? Method number two will be just draw the graph, and right here we did it. Just draw the graph and then observe whether there is a break, whether there is a sharp corner, then tell that okay, it's differentiable or not. And method number three, you guys know, is ninja technique, my favorite technique. and we'll do a PYQ of KCET by the ninja technique. Okay, so differentiability, you will be having like immense confidence of differentiability after this particular session, and we are not gonna take more than like 20 minutes to complete this thing. So today's session is going to be a little bit smaller session. Okay, yes. So now let us start with one problem. I'll take one problem. Okay, so the problem is you have to comment on differentiability. Comment on differentiability of function f of x at x equals to 1. Okay, so now your function is f of x equals to 2x or x square plus 1. This is when x is greater than 1. This is when x is less than or equals to 1. Cool, perfect. So this is your function and you're here to know the differentiability of function at x equals to 1. Now method number 1. Method number 1 is left hand derivative of this function is equals to right hand derivative. Do you remember the formula? Do you guys remember the formula? Derivative is what? Limit of f of a minus h minus f of a upon h with a negative sign where h is tending towards 0 plus. What is right hand derivative? Limit h tend to 0 plus f of a plus h minus f of a upon plus h. Now where exactly are you like seeing this differentiability? Where exactly are you like, so you're looking for x equals to a, right? X equals to 1. So here your a will be replaced by 1. So now this is f of 1 minus h minus f of 1 upon minus h equals to f of 1 plus h minus f of 1 upon h, right? Limit h tend to 0 plus here, limit h tend to 0 plus here. Okay, alright, so 1 minus h. Now understand what is happening. 1 minus h, okay. So you are looking for f of 1 minus h. That means you are looking for f of 0.999. Right? 1 minus h is what? Slightly less than 1. Slightly less than 1, that means right or wrong? So you have to put your 1 minus h over here. So basically f of 1 minus h from here will become what? 1 minus h whole square plus 1. Correct? F of x is what? X square plus 1. So f of 1 minus h will be what? F of 1 minus h whole square plus 1. So this is f of 1 minus h whole square plus 1. Correct? Minus, now understand this is f of 1. Can anybody tell me what is f of 1? So equality is right here. So f of 1 will be 1 square plus 1. So f of 1, if somebody asks me, it is 2. Correct? So this is 2. Perfect, upon minus h. Limit h tend to 0 plus. Let me just write down on the next page 1 minus h square plus 1 minus 2 upon minus h, limit h tend to 0 plus. Correct? Now just expand it. 1 plus h square minus 2h minus 1 upon minus h. Can you see again 1 cancel? H you can take common, h minus 2 upon minus h, limit h tend to 0 plus. H cancel and now you are having what? Basically you are having 2 minus h. And the moment you will put h tend to 0, your left hand derivative will become 2. Okay, so LHD is coming out as 2. Did you understand how did I calculate LHD nicely step by step? If you have any confusion, then your confusion will get clear while I do the RHD part. Okay, same. Limit f of 1 plus h. Now 1 plus h, that means you are looking for x greater than 1. And can you see for x greater than 1, we have to use this 2x. So f of 1 plus h will be twice of 1 plus h. Correct or not? Yes. So this is going to give you limit h tend to 0 plus twice 1 plus h minus f of 1. What is f of 1? 1 plus 1. So this is 2 upon h. If you solve it, what will you get? 2 plus 2h. So this is very easy actually. The right hand derivative is absolutely easy. So right hand derivative will become 2 plus 2h minus 2. 2 plus 2h minus 2 upon h, limit h tend to 0 plus step by step. Okay. Cancel, h cancel, so 2. That means our right hand derivative is also coming out as 2. If left hand derivative is equal to right hand derivative, that means at x equals to 1, dan, my function is derivative at x equals to 1. Okay, now let me just take some of your doubts, because I can see Abhishek is asking, ma'am, how 1 minus h whole square? How 1 minus h whole square? Okay. So just tell me, Abhishek, one question from you. You just tell me that if you have to figure out the value of 0.9, how will you calculate it? Think about it. Where exactly are you going to put 0.9? So you will think, okay, 0.9. 0.9 is greater than 1 or less than 1? Think. Ma'am, 0.9 is obviously less than 1. So x is less than 1 basically. Less than 1 is this branch. There are two branches. Can you see? You have to pick one branch based on what is x. Okay. So now this is your branch. Now you have to put 0.9 where? In place of x, right? So this is 0.9 square plus 1. Are you getting this logic? Are you understanding this? Let me know in the chat box. If you are understanding this, then so you will definitely understand why I am writing this. Okay. Now let me write. Let me just give you. Okay. Now if you're looking for f of 1 minus h. So f of x is what? Tell me, f of x is ma'am, x square plus 1. For x is less than 1. Now 1 minus h quantity, 1 minus h. You are removing something from 1. Obviously this thing will become less than, right? So in place of x, what will you keep? 1 minus h. Square is already there. Plus 1. So basically you are replacing x by 1 minus h. That is why this is f of 1 minus h. Are you getting it, Abhishek? Yes? Little. Even if you're not getting this method, I have told you this method because I want you to understand all the concepts. Although method number 1, we will very rarely for your KCET examination, because I told you which method we are going to use. So this is done. Method 1, LHD equals to RHD, done. Differentiable, your function is differentiable. Now the second method, graphical method. Are we ready for it? Same question we are going to do. Same question, right? So now f of x equals to same question I am copying, 2x, x square plus 1. This is x greater than 1. This is x less than or equals to 1. Now method number 2, which is graphical method. Graphical method. Okay, what is graphical method, ma'am? Graphical method is very easy. It says that you just plot y-axis and x-axis. Okay, and where are you looking for? At x equals to 1, right? So this is your x equals to 1. Now what is happening after 1? What is happening when x is greater than 1? So when x is greater than 1, you have to draw 2x, right? So basically you put y, this is x. You put y is equals to 2, you get x equals to what? 4. You put y is equals to 3, you get 6. You put y is equals to 4, you get 8. 4, 6, 8, correct? So this is 2. So the moment you put 2, you get 4. The moment you will put 3, you get 6. The moment you will put 4, you will get 8. So this is how and the moment you will put 1 over here, f of 1, although you can't put, f of 1 will be 2. So basically at 2, you will have a hollow circle. And this is how your graph will look like. Yes? Clear? Okay. Right? So this is when x is greater than 1. What about this? When x is less than 1. When x is less than 1, although, what about f of 1? Can anybody tell me f of 1? So f of 1, ma'am, you have to put 1 over here. So we have just calculated f of 1 is 2 basically. Okay. So this is your 2. So f of 1 is 2. So 2 is here. And if you want to draw the graph, and the moment you put x equals to 0, you're going to get 1. So this is how your graph will look like. Can you see? This is how your graph will look like. Okay. Alright. Now can you see this is the graph? This is the x square plus 1 part. And this is 2x part. Correct? Can you see at x equals to 1, we are having a smooth graph. Absolutely smoothness you can see over here. So that, what does that mean? There is no sharp corner, there is no jump, there is no break. That means my function is differentiable at x equals to 1. So graphical method, graph se to you will be able to see clearly, right? This is method number 2. Are we done with the graph thing? Now here comes the ninja technique. Are we ready for it? Technique in the chat box. You have to be a little bit interactive, because I will not tell you the ninja technique just like that. Okay, I will not tell you like within 5 seconds you can get answer. You don't have to do so much calculation. Within this you will get the answer from the ninja technique, my favorite method. Okay, so are we ready? Same question we will do with method number 3 now. Again, you have fx 2x x square plus 1. Okay, and this is your x less than 1, x greater than or equals to 1. At x equals to 1, you have to talk about the differentiability now. Okay, so now with this shortcut method, or you can call it as ninja method, okay, what you can do is you can find the left hand derivative and right hand derivative just like this. Now watch me what I do. Fx is this, right? Now I will be calculating f dash x. Okay, you can calculate f dash x. Now f dash x, this is 2x. Can anybody tell me in the chat box the derivative of 2x? The differentiation of 2x. Come on. I know that I have not taught you the differentiation of a few things, but I know that physics sir, the Shreyas sir has taught you, right? And you little bit you know that how to differentiate a function. So derivative of 2x is what in the chat box? Derivative of 2x is 2 over here. Okay, derivative of 2x is 2. Okay, and this is for x less than 1. Correct? Now what about derivative of x square plus 1? So ma'am, derivative of x square is 2x and derivative 0, and over here this is x greater than or equal to 1 now. So please avoid applying the equality part while writing the derivative. Okay, and by the way, this is method is not for school, not for your school or college or your POC. Okay, and now f dash x, you are here having here. Now where exactly do you want to check the differentiability? Tell me. Ma'am, we want to check differentiability at x equals to 1. So now LHD you will get when your x is less than 1. So your LHD is this. So LHD is coming out as 2. What about RHD? When your x is greater than 1, right hand derivative. So here you have to put 2x. So this is 2 into 1. 1 because we are checking the differentiability at 1. So again, can you see this is right hand derivative in a jiffy? You got this, and just put the value, and can you see, yes, the function is differentiable. How did you like my ninja technique? Yes, Preetham, yes, Rajat, you guys are absolutely killing it, nailing it. Okay. Now can we do one question? Can I give one question to you and you will solve it with the help of ninja technique? Are we ready to apply ninja technique? Are we ready to understand that whether we on our own are able to do any question or not using ninja technique? Okay. Chalo, let's now do one question. So question is right here. Check differentiability of function f of x equal to e raised to power 2x, x less than or equals to 0, 2 sine x, x greater than 0 at x equals to 0. Okay, all right. Yes, Kush Mohit. Also, one more, like, let me just make you acha, a disclaimer basically. Disclaimer says that whenever you want to apply ninja technique for differentiability, before applying ninja technique for differentiability, always check continuity of that function. Are you understanding what I'm trying to say? If you forget about it, then you will be like gone. You will be in trouble, in big trouble. Okay? Alright. Thank you, Supreme Soul. Thank you so much. So what I'm trying to say is, whenever somebody is asking about the differentiability, do not jump and just think only about differentiability. No. So what you will do is, you will be like, okay, you are asking me differentiability, I'll be checking continuity, right? So just give the question some attitude, like ask me differentiability, I'll check for continuity. Why? Why will you do that? Because you are Ninja Ma'am student, right? And Ninja Ma'am has told you that before differentiability, there is a step called continuity. You can't be jumping into differentiability before continuity, right? If this function is discontinuous, then we will not talk about differentiability. Hello, right? So let's do that. Now at x equals to 0, correct? So first of all, let's check the continuity of this function. So we know that at x equals to 0, if we are checking the continuity of this function, then f of 0 plus is equals to f of 0 minus is equals to f of 0. Just one step, okay? Now f of 0, can anybody tell me what is f of 0? So ma'am, hold on, f of 0. For f of 0, what you have to do is, you have to put 0 over here because the equality is here. So e power 0. So this is actually 1. What about f of 0 minus? So 0 minus means x less than 0. So again this branch you will use. Again this is e power 0, that is 1. But ma'am, hold on. What about 0 plus? So for 0 plus, x is greater than 0. 0 plus, that means right after the 0. So it is going to be 2 into sine 0 plus. 2 into sine 0 plus. So can you see this is sine 0 is what? 0. So okay ma'am, hold on. So the function is discontinuous. If the function is discontinuous at x equals to 0, then we will not check continuity now. No need for differentiability check. No need for differentiability check. No need for differentiability check. Okay. Yes. No need for differentiability check. Now, suppose if there is a student who is not a Ninja Ma'am student. Okay. If a student who is not a Ninja Ma'am student, and if he used to apply, if he wished to not a Ninja Ma'am student, see how a student will make a mistake. I am taking this time, okay, to tell you that how exactly you're going to lose your marks in your KCET examination. So he'll be like, okay, the question is asking about differentiability, I will check about differentiability. Okay, so what will he do? Tell me. So he'll be like, okay, f dash x, let's figure out. So e raised to power 2x, the derivative of e raised to power 2x will be what? E raised to power 2x into 2, and derivative of 2 cos x. Do you know the derivative? Now this is x less than 0, this is x greater than 0. Now for LHD, you have to plug in 0 over here. LHD at x equals to 0 will be what? 2 e power 2 into 0. So this is 2. What about RHD at x equals? It is going to become 2 into cos 0, that is again what? 2. So he will say LHD is equals to RHD, and he will say yes, differentiable. Oh my god, big mistake. Can you see, can you spot the mistake? This is a mistake. I am cancelling it. Mistake. Okay, even though he is able to get LHD and RHD equal, but because the function is discontinuous, even though LHD RHD are equal, function is differentiable. Are you understanding my point? Have a look. Let me know in case of any doubts. If you guys are having any doubts, let me know. Okay, all right, you should understand, like, you guys are in safe hands. Okay, I will like not at all leave you alone, and I will not let you make any mistakes in your KCET examination. Okay, this much trust factor you have to now make on me. Okay, is it clear? Are we good? Are we good? Okay, Abhishek, you are saying no for what? Okay. All right. So now we will do one question which was there in KCET examination. This is the KCET PYQ. Half PYQ we did while doing PYQ. Will be doing today. Okay. So this is a function at x equals to 1. This function is this, right? And at x equals to 1, we are looking whether the function is continuous or not. So let me just tell you that for continuity, obviously, if you want to check differentiability, continuity at x equals to 1, tell me. Yes, ninja trick. Again, I will explain you gods in with the help of this question. Okay. Yes. Yes, Abhishek, we are already on the last PYQ. Okay. So now continuity. So ninja technique says that whenever differentiability of a gods, now this is for you, I am repeating. Ninja technique says that whenever you have to check differentiability of any function, do not check differentiability first. First you check equals to 1, and it is like it will take hardly 5 seconds to take continuity, right? Continuity at x equals to 1 will be what? F of 1 plus is equals to f of 1 minus is equals to f of 1. What is f of 1? Ma'am, f of 1. Wait. Let us check. So equality is here, right? This is equal sign, x equal to 1. So this is 1 minus 1. So this is 0. Getting it? Okay, alright. Now f of 1 minus, that means x is less than 1. Again you will use like x less than 1, that means again you will use this branch. So you have to put 1 over here, 1 minus 1. So this is again 0. Okay, till now we are very safe, cool. But now f of x, f of 1 plus, that means x is greater than 1. Can you? So 1 you have to put it over here. So 1 cube minus 1. So again 1 minus 1, this is 0 equals to 0 equals to 0. This we have already done in last class. So the function is continuous at x equals to 1. Now you can peacefully apply the ninja technique. Ninja technique says that it's very easy. Now if you want differentiability check, at x equals to 1. Now listen. F dash x. So you just have to simply differentiate, nothing else. So this is x cube minus 1. Derivative of x cube minus 1, who is x cube? Derivative of x cube is 3x square. And derivative of minus 1 is 0. Okay, ma'am, cool. And this is when your x is less than infinity, greater than 1. Okay. And what about this differentiation of x minus 1? So derivative of x is 1. Derivative of 1 is 0. Right? I am assuming that you guys know a little bit differentiation, right? Am I assuming incorrect? Am I like doing something wrong over here by assuming? So 3x square and 1. And this is x is less than 1 and greater than minus infinity. Just one thing, you can't apply equality anywhere. And now this is what you have. Now what you are looking for is LHD, that is left hand derivative at x equals to 1. So for x less than 1, when x is less than 1, can you see x is less than 1, your differentiation is 1, so LHD is 1. What about RHD, my dear students? So when RHD is there, so you have to, so RHD means x greater than 1. Where is x greater than 1? This branch. So you have to put 1 over here. So 3 into 1 square. Oh my god. RHD is 3, my dear students. RHD is 3. Can you see? RHD is 3. Alright. Okay. And for all of those who have not liked my session, do like it right away, huh? Because like this amazing technique I am teaching you. So yes. So RHD and LHD both are not equal. So which option is correct? Tell me. Which option is correct? The function is continuous, but it is not differentiable this time. Yes, Abhishek. So continuous and non-differentiable, that means B option is absolutely correct. So KCET question done nicely. KCET question done. Yes, Kush Mohit. Yes, gods. Now you know it. Now you understand it. Yes. Okay. All right. Now the next lecture is going to be methods of differentiation. Next lecture is going to be about how to like differentiate x raised to power n, what is the derivative of sine x, what is the derivative of cos x, product rule, quotient rule, chain rule, logarithmic differentiation, and so basically how to differentiate a function. So next lecture will be there in the next week, right? Most probably on Monday I'll be seeing you, Monday or Tuesday. Okay, so yes, I guess that's about it. So today's session, we are done with today's session, guys. And yes, okay, cool. Now if you guys are having any doubts, you can reach out to me on my Telegram, t.me/Namrata Jaisinghani, and today you guys have wished me on the chat box. Today you guys have wished me in the like community post. So thank you for very warm wishes from you all. It means a lot to me. And please give timetable. Yes, we'll be sharing the timetable very soon on community post and in Telegram as well. So stay tuned, and this is me, your Ninja Ma'am, signing off. I'll see you all in next video super soon.